users. In this video, I'm going to show you how to do the measurement of the inertia tensor of the testing platform, the testbed platform, and the DUT. For the platform itself, it is defined as the case where the DUT is installed on top of the testing platform. Here is how we are going to measure the inertia tensor of the platform. As we already measured its center of mass in the previous section, we are able to estimate the external torque on the platform that is created by gravity. Then we can measure the angular acceleration and angular velocity from this gyroscope here. Considering the dynamics of a rigid body, we can estimate the inertia tensor of the platform through our testbed TYF software. In addition, the inertia tensor measurement should be performed once again for the testing platform. By comparing the results of the two, we can obtain the inertia tensor of the DUT. Please note that once you move the position of the DUT on the testing platform, the inertia tensor of the testing platform will change. Therefore, the user better keeps the DUT stationary on the testing platform for the entire mass properties measurement process and the ADCS functional test processes. During the inertia tensor measurement procedure, to obtain a varying but known center of mass position, one should also hand the calibration weights into 6 different configurations. These 6 different configurations will transfer the center of mass of the entire platform to 6 different positions. So that means when we excite the platform manually by our hand for it to vibrate, we can obtain a series of meaningful angular velocity and acceleration data for us to extract the mass properties. So we need to repeat the procedure over and over for 6 different configurations that are matched to 6 different handling combinations of the calibration weights. And for each configurations, we have to repeat the manual excitation twice.
So once again, we start by clicking this panel to choose whether we are going to measure the inertia tensor of the platform, of the testing platform. When we enter the panel, we should choose which condition we are measuring. After clicking here, we should make some settings for the selection of our large calibration weight and the small calibration weight. For example, we choose the large calibration weight to be B and the small calibration weight to be A. The small calibration weight could also be none as long as the larger calibration weight is not none. Then we follow the instruction here to execute the testing. Then the user excites the platform for it to rotate by its dynamics. And we can click Start to make it record 1 minute of raw data. And after you finish that, the software will stop by itself, or you can abort the process. So after we take these measurements and complete all these configurations, we are able to calculate. Click the button Calculate. Then we have the inertia tensor for the platform.
Each excitation recording raw data will last for 1 minute. The testbed TYF software will support this recording and proceed with the calculation for the user. Once these 12 sets of measurement cases are completed, the testbed TYF will calculate the inertia tensor for the user. When you measure with the testing article, the inertia tensor will obtain is the inertia tensor including the testing platform and the DUT, and reference to the center of rotation. When you measure with the case without a DUT, you will obtain an inertia tensor that is referenced to the center of rotation but without the DUT. Comparing these two results, the user can obtain the inertia tensor of their DUT on the platform reference frame. So this is an introduction to how you can measure the inertia tensor of your testing platform and DUT. In the next video, we will show you how to execute the ADCS performance tests. Thank you for your listening.